There is a line of people waiting for a store to open. The amount of people outside doubles every hour. At 5 a.m., there are 4 people in line. How many people will be in line at 8 a.m.? Chloe is here with her latest tips and tricks. She wants you to know that when you have a geometric sequence, you will be multiplying the same number when you're going from left to right, and you will be dividing the same number if you were going right to left between each pair of consecutive terms. The common ratio finds the ratio between two terms. It's r equals a sub n divided by a sub n minus 1. The recursive rule does depend on one or more previous terms to generate new terms. That formula is a sub n equals r times a sub n minus 1. And the explicit rule does not depend on previous terms to find the nth term. That formula is a sub n equals a sub 1 times r raised to the n minus 1 power. Now that we have Chloe's tips and tricks, let's go ahead and figure out how many people will be in this line at 8 a.m. So the first thing I notice is that at 5 a.m., there were 4 people in line. So that's my a sub 1. They're telling us at 5 a.m. there are 4 people in line. So I put 5 for 5 a.m. in parentheses. Now, it says it doubles, the people outside double every single hour. Doubling is the same thing as multiplying by 2. So we found our common ratio, which is r equals 2. Now that we have our common ratio and we have our first term, we can go ahead and make a recursive rule so we can find the other terms in our sequence. The recursive rule is a sub n equals r times a sub n minus 1. So if we are looking for our next term, we would just have to plug in our r, which is equal to 2, and then we can write the recursive rule as 2 times a sub n minus 1. To write it formally, you should just put the 2 and a sub n minus 1 by each other. You should remove the multiplication sign. And anytime you write a recursive rule, you always have to say where you started. A sub 1 equals 4. So now that I have this recursive rule, let's go ahead and find a sub 2 at 6 a.m. So I'm going to plug in 2 for my n. That would be 2 times a sub 2 minus 1, which reduces to 2 times a sub 1. Well, our a sub 1 is 4, so 2 times 4 equals 8. So our a sub 2 is 8, or at 6 a.m. in parentheses for 6 a.m. Let's try to see what it is at a sub 3. So we can do a sub 3 equals 2 times a sub 3 minus 1. Then that would reduce to 2 times a sub 2. And we'll take our 2, multiply it by a sub 2, which is 8, and we end up getting 16. From here, we can try a sub 4, which is our next hour. So we see we're at 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock is our next one. So that's a sub 4. 2 times a sub 4 minus 1 reduces to 2 times a sub 3, which is 2 times 16. That was our a sub 3, which equals 32. So I can see that after there'll be 32 people in line at 8 a.m. And you can see we just did that by using the recursive rule to find each one. Now, we could have also used the explicit rule. The explicit rule, remember the recursive rule is the one that you have to know the previous terms. Notice each time that I found my next one, I had to know the previous term to get to the term I wanted. When you're using the explicit rule, you don't have to know the previous term. So the formula for explicit rule is a sub n equals a sub 1 times r raised to the n minus 1 power. So I can substitute a sub 1, which is 4, substitute that in. My r, we know it doubles every hour, so my r is 2. And we can write that explicit rule, dropping the multiplication sign and putting parentheses. So that's 4 times 2 raised to the n minus 1 power. Now, with the explicit rule, we just have to plug in our 4, because 4 is the term when it is 8 a.m. Notice how that's the only thing I had to plug in was the 4. I don't have to know what a sub 3 is if I use the explicit rule. So I really have 4 times 2 raised to the 4 minus 1 power, which is the same thing as 3. 2 cubed is the same thing as 8, and 4 times 8 is 32. Remember, the recursive rule is helpful when you just have a few you have to do because you have to know the previous term. The explicit rule is best to use when you're looking for a number further in your sequence. And you can use both of them on some occasions.